good afternoon, good morning, good evening, depending on where you're logging in from. Great to have you all here today. My name is Don Cook. I'm the Chief Marketing Officer at 7Signal. And with me today is Mr. Dave Hallis and Jim Vada. For those of you who are regulars here, Jim runs the show every week here. Normally Kelsey joins you all and is the MC. I'm going to be filling in for her in the coming weeks. And Mr. Hallis is our guest star today, and he's got a great topic for you all, IEEE 802.11az and the next generation positioning. So before we get started, I'm going to walk through a couple topics, and Dave's going to introduce himself for those of you who are not familiar with Dave. A couple housekeeping items. We'd never do any product tours on these webinars. Today is going to be no different. We may refer to our products as time goes on. But if you would like a product tour, you can go to go.7signal.com/tour, and you can access that. Every Friday we do a tour on our products, so you can get all the information you want on our products and services there. If you're looking for an archived webinar from us, you can get access at YouTube on our channel. Just search 7Signal, really easy to find. These events are certified by CWNP, so you can get your certifications for those of you who are continuing your education in Wi-Fi. And exciting news, we've got a podcast coming to you all soon. This same great content is going to be served up via your favorite podcasting tool. So more details to come there in the future. So for those of you who don't know who 7Signal is, just really quick, we've been around since 2007, and we've hit a lot of major milestones along the way. We're monitoring millions of devices, crunching a lot of numbers, over 1 billion data points on a daily basis for our customers. We've got over 200 around the world, over 30 partners, resellers, and distributors around the world. We're in 35 of the Fortune 500. We continue to grow upmarket. We are GDPR compliant. For those of you who are logging in from the EU, that will be relevant to you. So not only do we stay up to date with our technology, but also your privacy is paramount. And we've got over 15 patents that we continue to build on. But why we're all here is Wi-Fi continues to be more strategic in your enterprise networks. And really, Wi-Fi more than ever is powering the business. As new buildings go up, smart buildings go up, they're not being run with wire Cat5 cable. They're being deployed as wireless buildings. So all of your applications being run, all of the back office software, all the distribution centers, all of those critical components of your business are run by Wi-Fi. So digital experiences and user monitoring is more critical than ever before. And what we focus on here at 7Signal is helping businesses understand there's 8 pain points for the business, and we're helping give visibility into those. And there isn't one company on this call today that doesn't experience these sorts of pains. Whether it's engineers being more reactive than proactive with troubleshooting and preventing wireless issues, or spending too much time trying to find those issues and being less strategic within the organization, finger pointing back and forth between the network teams and the device teams or the application teams. We've heard it all before, all leading to either poor satisfaction, losing revenue, or in healthcare situations, certainly impacting medical errors, patient satisfaction, etc. So our software gives a more complete view of that. This slide right now showing half of that view, and a lot of you have these current vendors deployed, whether it's your access points or Riverbed or AppNet or SolarWinds. There's so many more folks playing in that space that look at the infrastructure, can give you great information about what's happening with your infrastructure, what's failing, what applications are failing. Sometimes they can tell you why. But where they lose sight and where we pick up the ball is from the outside in. So really looking at those endpoints, giving you visibility into end user experiences, either on the device or in the air, giving you service level quality and visibility through our Sapphire Eye or Mobile Eye products. So real differentiation for us in that market space. And a lot of times we're lumped in with the inside out vendors but definitely not the case. So we'll get on with the show here, and we're going to start off with a trivia question that Dave put together for us. So I'm going to share that up, and it's true false. So I can't give away swag with a true false question. It's just you got a 50-50 chance here. I think you guys will agree. I don't have enough pencils or pens to give away for true false stuff. So let me flash up this first question here. Again, true false. Bluetooth tags use an early draft of IEEE 802.11az. True or false? And Dave, while they're pecking away at their keyboards, why don't you lead into an answer here, and then I'll share it.
Well, so when you mentioned Bluetooth, Bluetooth is actually under 802.15, so that would be false.
Let's see how they did.
Our audience has a lot to learn today.
Yes, it's going to be a very eye-opening experience for all of them. 64% of you were incorrect in this case. But that doesn't matter. We're going to teach you all about 802.11az today, and I'm going to hand the controls over to Mr. Hallis, and he's going to kick off today's show. So Dave, the controls are yours.
Okay.
Jim, that question didn't confuse you, I imagine, though.
Oh, not at all. Not at all.
Okay.
Don, I still see the poll.
Well, not for long. That poll is
There
gone.
we go.
Oh, there we go. Okay. Now,
sorry about that.
There we go.
What do you see? You're able to see the screen. So about Dave Hallis.
Looks good.
Cool. Stuff about myself. I'm a solutions engineer here at 7Signal. CWNA certified, over 25 years of wireless experience. Was recognized as a Cisco innovator. Had to do mostly around the security side, the early days of 802.11. 802.11i was the task group chair for that. And that was for the enhanced security. People are old enough that they remember all the problems with WEP. Yeah, I lived through all that. And then also I was the initial task group chair for 802.11ah, which is for sub 1 gigahertz operation. I was also involved with the formation of the Wi-Fi Alliance. Back then it was known as WECA, and I got a number of patents as well. So now I'm just trying to figure out how to get my...
Might have to engage into the application.
Yeah.
Sometimes when you share it, yep, there you go.
So next generation positioning implies that there's a previous way of positioning. And yeah, there were a number of ways to get positioned. For instance, like signal strength, and we'll get into that a little bit. And then there's timing measurements, and there's other technologies, as we kind of let off with the trivia question. And then we'll get into next generation positioning. So signal strength was the one that I kind of let off with. There's and as you kind of see here, what I'm trying to get across is that an access point that's farther away, that the signal strength will be lower. So you can kind of use that as one way of figuring out the location. If you get like 3 access points and you're a client and you say, oh, well, I can kind of see that the signal strength is of these different access points. And then if you know where those APs are located, you can get a rough idea. You know, for instance, you know, if you're like a real rough idea is if you know what access point that you're associated with, you know that you're in that general area. So if you know the signal strength, that'll give you an even better idea where you're at. Now, there are some kind of problems, you know, if you just think about it a little bit, that a lot of the wireless systems out there, they'll change the channels automatically and the signal strength that they're outputting, for instance, if you're doing high density. So now there's no guarantee that all the access points are using the same transmit power. So obviously, the using that signal strength is going to be, that's going to complicate things here.
Yeah, Dave, another issue here is the design requirements for signal strength-based location services are usually a trade-off or conflict with what you'd want to do for the best possible Wi-Fi performance. So a lot of times you need a lot more APs, so you can do the triangulation, and you want to have, your perimeter totally surrounded by APs. So you have to accept a little bit more co-channel interference and, suboptimal AP placement for performance, at least.
Yeah, and so that initial way of doing things kind of had a very limited life cycle. It kind of worked out for a little bit, but as Jim was kind of mentioning, there's a lot of things that kind of work against it. Now there's kind of timing measurements, and I'm sure that all of us remember these types of questions when you're in grammar school. It's like, if a train leaves Chicago going about 60 miles an hour, then how many glasses of wine can I drink? Right? Well, that might not be the question in grammar school, but it was for my school, but maybe not your school. Now, one of the issues
how much milk could you drink in grammar school?
That's right. Now, the other thing that we were talking about trade-offs on technology, that's one of the trade-offs here is, I'm not sure if everybody's aware of it, but the speed of light is like really, really fast. And so now if you're trying to measure something relatively close, that change is, it's going to be a very short time period. So that's kind of like one of the things that would work against you. But there is a way that you could do this right now, and it's actually in the Wi-Fi Alliance Wi-Fi location program. It uses the fine timing measurements. If we go back and looking at the 802.11v amendment, that one brought in the timing measurement procedure. And then that was followed up by 802.11mc, which led to 802.11-16 with the fine timing measurement procedure. That fine timing measurement procedure, that was kind of a clarification. It added a lot of text around, made it clear as to how you could kind of use this. And just kind of like we were talking about using the train example of, if you know how fast you're going, you know what the distance is going to be. It's the same thing with this fine timing measurement, that what you could end up doing is saying, if I know that it takes a certain amount of time to get from the access point to the client and vice versa, you can then calculate what that distance is. There are some things that kind of complicate that. Definitely, that's one of the things is that different clients, that the clock rates could drift a little bit. And so therefore you kind of have to take that into account. So you'll see that there's a number of exchanges, and that's kind of like what they're doing is they're trying to get rid of that impact and then to say, okay, this is actually what the distance is like. Likewise, when you're getting the distance, there's other things that could impact that. For instance, you could be getting reflections. So the reflection is obviously going a different path. It might be going off something kind of coming back. So that distance might be a little bit longer. But this is better than that signal strength, definitely. And that is kind of mentioned that actually this is in the Wi-Fi Alliance. I actually do have a program for this so that you could actually get your product certified. So if you do buy a product and you see that it's got the Wi-Fi location certification on it, that it does have this capability.
Yeah, a nice thing here too is that you only need one AP and one client. You're not doing any necessarily triangulation to get a distance measurement, at least from the AP. You just need a AP and client that support the protocol, and you can figure that out.
Yeah. Now, obviously, if you did want to kind of get to the location, triangulation will help you out. Right. And there is more to it as well. For instance, being able to that the access points could do this to themselves, so that they could say, okay, I know what distance these devices are. And then when a client says, I want to know what location is, you can start to infer that, this is what the location of. So there's a lot more to it. But for our purposes, just trying to get a sense of, what exactly is kind of going on underneath the hood. This is basically what's happening. There are other technologies out there. As we kind of do, but I thought that was going to be an easy one with the BLE question, especially when Don mentioned Bluetooth, that would kind of give it away. But you'll find that there's a lot of vendors that do have these support BLE tags, and that also, besides having obviously the Wi-Fi radios on them, that they actually have the Bluetooth low energy radios on them as well. And that kind of helps you for being able to, there's kind of renditions on, how this would end up being used. Basically, you can take one of these tags and you can put it onto like a palette, and now you can kind of track that through it. Likewise, you could do things like being able to track, giving it indoor directions to something, or also kind of like sensors. Maybe you have a temperature sensor, and that's communicating what the temperature is over Bluetooth Low Energy. So there's a number of use cases, very similar, but it's definitely a smaller distance. It's a different technology. There are some other technologies I didn't mention it here, but obviously there's, for instance, I think Apple made up press release on the AirTags a little while ago. That's another technology as well. It's ultra wideband. So there are other technologies in this area, but then also within Wi-Fi, kind of one of the advantages is just using the same technology that you have in there. Here's some slides. This is actually from some of the work that's within the Wireless Next Generation group standing committee within 8.11. Wireless Next Generation, this is where if you had something where you wanted to socialize and say, I think that there's some work that we should be doing, and you wanted to socialize that somewhere, this is a committee to do that. In where a number of people kind of bringing up saying, hey, I think we could do better on the next generation positioning. And they kind of discussed this. I like this slide because they kind of talked about, well, the RSSI, they kind of give you a certain level of location, and they were kind of saying, oh, there's time of departure. Just saying, if all I'm doing is saying, well, just measure how long does it take to get, you kind of figure it out. The fine timing measurement kind of improved on that. And what do we want to do about going next? Well, obviously, you wanted to improve, make the accuracy even greater than that. If you did want to see the full text, there's a link to where you could actually download it. Likewise, the use cases that they're talking about, that one of the things you see with the fine timing measurement is that it's a bit chatty. They did try to optimize that a bit, but those are kind of like, I believe those are action frames. So you kind of have to set this up ahead of time, and then you're kind of going off and doing these measurements. Is there a way to kind of like lighten the load there? That would be nice. And then, so obviously like in a stadium, that's, there's two factors there. You've got, one is that you've got a ton of people, and these access points, where exactly are they located? And then there's some of all the traditional use cases of kind of being able to find your way through and knowing that, oh, you're by a certain store or something like that. I'll also like this little note here about enabling the use of fine timing measurement and below the 1 gigahertz. I didn't actually look at the details of that, but it was an interesting note.
Dave, you should be all over that.
I don't think that I would. But I did. I was like, well, let me just kind of get through some of this other stuff. So kind of highlighting it, one of the other webinars I kind of mentioned, the PAR, is you have to say what you want to work on. So this document is important from the standpoint of you're saying, this is what I want to do, and then you get authorized to go off and do that. So if you kind of come out and you do something, instead of positioning, you said, well, you come up with a new 5, they're going to say, that's not what you were approved to do. You're approved to do something on positioning. And so what are they looking at? They didn't actually say what kind of accuracy they were looking at from the use cases. They just said, well, we want to be better. A little bit of a cop-out. I think that if Don was the marketing guy there, he would have told them, no, you got to look at your use cases and work backwards. Scalable to dense deployments. Kind of like that stadium type of use case. You got to be able to scale a little bit. They also kind of mentioned, and this is kind of interesting, enable a secure exchange. I'm not going to get into this too much into the details, but that was kind of interesting. See, since some of these things are very passive, that being able to add some security to it. And then they also kind of mentioned backward compatibility, that since there's already this fine timing measurement in there, trying to build on that, making it so that you're kind of like able to use some of the older protocols if needed, but if you have something that you can work with better, be able to use that as well. Likewise, if you did want to get into all the gory details, there's a link to that at the bottom, tell you where you can kind of grab it. A little bit of background before we get into this next generation position. I just want to give you a little background, and then I think you're going to see where we're going to kind of go with this. Beamforming, that there was beamforming in 8.11, for instance. There was a lot that was in the 8.11n, and I think the common comments about it is that there was two mechanisms, and so it really wasn't, it didn't take off as well. 8.11ac said, hey, we're only going to come up with one form of beamforming because we want it so that everybody kind of goes off and deploys the same thing. How does that work? There's these null data packets. So null data packets, it's kind of easy to think of. It's a data packet, doesn't have any data. And what are they used for? That they're used to measure the challenge. So now you think about it, beamforming. Oh, it's the access points in the client. They're sending in the direction of the client, right? So, well, if they're doing this, well, hey, so we will know where that device is located by doing sort of that same thing. And so what you'll see is that there's a lot of discussion about in this area about angle of arrival and angle of departure. So instead of the fine timing measurement where they talked about time of departure, this is when I sent the packet, and time of arrival, this is when I received the packet, that you get this angle of arrival and angle of departure. So now, just like before, instead of thinking of it as far as in time, if you know where exactly that you have to point the antennas to get to something like for beamforming, that by doing that same type of null data packet ranging type of measurement, you could then figure out, well, what the angle is. Now, if you know, well, this is where the access point is located, and if you've got at least three, you can kind of do that same triangulation to figure out, oh, this is where that device must be at. The advantage here is that, as I kind of mentioned before, with the fine timing measurement, really what you're doing is you're measuring the speed of light. It's like, oh, well, the speed of light is X, and it took this long, so therefore this is kind of like what the distance is. Here, you're just kind of using an angle to get a finer resolution on where something is located. If you actually do kind of want to look at the actual drafts and so forth, they'll talk about non-trigger based ranging. And so that's where in the fine timing measurements, there is this, oh, we're going to set up and do this measurement. That's kind of like the trigger. Here, you know, this doesn't need that trigger, and it's using these null data packets instead. So obviously, as the null would imply, that the packet is much smaller. So therefore, you're actually just trying to do the phi channel measurements on the packet as it's being received, to then to figure out, oh, okay, this is where what that angle is to get to that device. So therefore, that's going to scale a lot better for you. Here's a bunch of references. If you did have, like, as I was going through looking at the Bluetooth Low Energy, I thought that I'd put that out there. So if we do kind of put some of the stuff out, you'll be able to kind of look at those. This is where I take a breath and say something to Jim, like, I welcome Jim, and see if we got questions that we could kind of go through.
Yeah, thanks, Dave. Really interesting there. So first question from Tom, he wants to know if timing measurement or fine timing measurement is supported by anything out there on the market yet. And Tom, I can tell you that in the enterprise space, I think Aruba is the first AP vendor to support fine timing measurement. They've got that on the 500 series APs with 8.8 code or newer. And in the consumer space, Google has been a big driver of this. So they support fine timing measurement on Android 9 and above. You need a Pixel, I think. I don't know if the other hardware, other phones work with it. and their own Google Wi-Fi APs support it. Anything to add to that, Dave?
Yeah, I think that that's like a good point. There's usually that's the people that are involved in the standards process. Obviously, the IEEE is a standards body. It's not a research institute. So it's usually it's like people that are involved for a reason. They want to get something to product. So if you look at, can I mention 802.11v is where the first timing measurement came out. You know, that was chaired by Aruba. And then 11MC was where that was clarified a little bit more. That was also kind of clarified or that was chaired by Aruba. And so therefore, obviously that they were doing a lot of work to kind of move that in. So it makes sense that they kind of like went forward and then kind of like put that into product. So it's actually kind of cool that you can actually see some of the product that's out there now, and that they're looking at the next generation of how things can kind of actually go even further.
So a question from Sandeep. He says, can GPS positioning be used to enhance the 11AZ triangulation positioning? Some outdoor APs have now started to offer GPS antenna with 1 PPS synchronization.
Yeah, I mean, the comment there, you know, which was in the question itself, was that's outdoor. So obviously, you know, when you go indoor, then GPS is less of a value. And that's where things like Bluetooth Low Energy and the Wi-Fi location is going to help you. So it kind of depends on your use case, I would say. I don't know, Jim, if you had anything else you were thinking about.
Yeah, one of the things, couple thoughts there. I think, you know, this is sort of, it's like a building block that's part of a complete RTLS solution. So you could have a system that's ingesting fine timing measurements and next generation timing measurements, along with GPS positioning data, even BLE location data, and kind of putting that all together into a location package. So I think so. The other thought that comes to mind is one of the things supported by the protocol, besides the the distance and timing measurements, is just providing what the standard calls a civic location. So that could be a street address or other things like that, just as part of the exchange to get some more general location metadata, if you will. You can even provide a URL to a map. The standard allows that. I'm not sure if anybody's going to support those kind of things, but there's a lot of options there.
I agree with you, Jim, that it's, the more data that you have, the better. So if you have all that information in front of you, it's kind of like you're able to then pick and choose and, combine things to say, oh, let's get a finer idea of what the location is.
Important question from a friend of 7Signal, Olivier, who says, are the location measurements performed by the infrastructure or the client device?
Good question. I believe that those are done in both directions. That kind of had to do with the angle of arrival and angle of departure. And so you're kind of getting it in both directions. I know that with the fine timing measurement, you're doing it, you're basically going both directions.
Yeah. And so the client can end up with the location information itself. So then it kind of has more of a BLE feel to it, right? You've got an app that's running, it needs location, you've granted it the location permission, and now it can learn something from fine timing measurement and 11AZ about its location as well. Anders says, will 11AZ use or not use MIMO?
Will 11AZ use MIMO? from the perspective of, yes, that MIMO is still within beamforming. So I don't know if the question had to do with OFDMA. So because it actually came in through AC. So I'd say yes.
Yeah. Another question from Anders, more of a comment really. Angle of arrival, so we're getting back to the Cisco hyperlocation antenna array. And those are similar concepts. The Halo array from Cisco was this kind of big bolt-on, antenna array that gave angle of arrival information in a proprietary way for Wi-Fi based location services. So I guess the question is, Dave, will this require special hardware? Are you going to are there antenna requirements that are going to go into this?
I would say that I want to coach my answer. So I would say that if you've got something like 802.11ac that's able to do beamforming, then you could use that same type of technology to get the angle of arrival and angle of departure because it's using the same mechanism. Now, you are correct. If you wanted to increase that resolution, then you can have some options on your antennas. So that I kind of say, for my home AP, that should be, it's got, like 3 antennas. That's sufficient to be able to get location. Do I want to get something finer to get more resolution? Yes, that a different technology antenna could kind of help you out there.
Yeah, and maybe one last question here, Don, and we'll wrap up. Another question from Olivier. Can you confirm that we won't need to alter our original RF design to support next gen positioning? Or does it require a new design, like 3 or 4 APs that target RSSI, for example?
I think it does, Jim, we talked about this a little bit. It does kind of like put some requirements about when you deploy them, how you're doing that deployment. You can't just slap it up there and then expect things to work. I think you need to, since you're talking about the angle, not just the timing, that means that you need to know the orientation of that. It's not just that it's put up there, but when it's put up in a given orientation.
This is starting to sound familiar.
So it's, it does make things a little bit more, complicated, that when you're having somebody install it, how high is it? What orientation of that access point? That there will be some requirements there rather than just a slap it up there. It's good enough.
Yeah, maybe, hopefully though, the RSSI requirements are not as strict as they are now with proprietary 802.11 location services. Because one thing I've noticed in playing with this is I can get fine timing measurements at 100 feet away from an AP with a signal strength in the low neg 80s. So potentially you won't need the same amount of density, I'm hoping.
Yeah, that's actually a good point. I can't remember the details of it explicitly, but they did kind of bring up where different technologies work best with different signal strength. So that I could see that definitely, being an impact as well. So.
All right, great.
Awesome. Gentlemen, thank you so much. Dave, great job on the presentation today. Jim, always thanks for pulling us along and adding some color as we go. Everyone, thanks for joining us today. Again, if you're looking for product information, go to go.7signal.com/tour. And today's presentation will be posted on YouTube in about 2 hours or so. Just need to edit and pull everything in and post up online. And if you're looking for CWNP certification credits for today's webinar, all you need to do is reply to one of the emails that you get from me surrounding today's webinar, and I'll get you to the right place. And again, our presentations are coming to a podcast near you, more details to follow. And if you check us out on YouTube, don't forget to smash the like and subscribe button, I think is what the kids say. Am I right, Jim?
That's what my kids say, yes.
Appreciate you all coming today. Have a great week. We'll see you all next week.
Thanks, Dave. Thanks, Don.
Thanks.